Hello class, a very warm welcome in today's session. In the today's session, we are going to continue our chapter that was matter. In the previous two sessions, we have studied that what is matter, what are the different states of matter, and we have also linked the kinetic theory of matter with the states of matter. In the previous session, we were studying the kinetic theory of matter and the change of state. As we have studied that whenever there is a change in temperature, like if we are increasing the temperature of the matter, like the state of matter, so what will happen? The molecules will start moving from here and there. They will just start vibrating at their mean position, which means that the kinetic theory increases, right? Or kinetic energy increases. Okay, so the kinetic theory of matter can be used to explain the change of state in matter. By changing the amount of energy carried by the molecules, the state of matter can be changed. If the molecules gain heat energy, they start moving faster and away from one another. However, if the molecules lose heat energy, they slow down and move close to each other. Now, what will happen that if the molecules are releasing heat energy, so they will just come back close to each other. But if the molecules are gaining heat energy, or we can say kinetic energy, so they will just move apart from each other. Okay, so this is what is the interlink of kinetic energy with the change of state of matter. Moving ahead, you can see that firstly we are going to study about the melting or fusion. Here we are going to study what? The change of state of matter, okay, from one state to the other state. There are different processes and different definitions as well. So you can see, let us understand the different processes of change of state in matter with the help of kinetic theory. The very first process is what? It is melting or fusion. So in the previous classes or in the lower standards, I hope you have studied that what is melting and what is fusion. As you can see in the image as well, that there is an ice cube which is melting here, right? It is changing its state from the solid to the liquid. So it means that it is changing the state from solid to the liquid, which means that there is a change in the kinetic energy of that particular state of matter, right? So it is written here, when a solid is heated, its molecules gain kinetic energy and become very active. So what happens if we are just increasing the temperature of a solid? So its molecules will gain some sort of kinetic energy and they will just start moving from here and there and they will be very active, right? They try to overcome the intermolecular forces of attraction. So they vibrate faster, resulting in an increase in the intermolecular space between them. Now what will happen that they will move faster from here and there, right? And which will just affect the intermolecular space, which will just maximize the intermolecular space, right? If I am saying that this is the ice cube, let me just show you the diagram. So it is the ice cube and there are molecules just like this. Molecules are arranged like this, okay? We can just imagine that. So what will happen if the ice cube will be heated? So what will happen? The molecules will start to move here and there, right? They will just start vibrating. So after vibrating, the space between them will be maximized. And if the space will be maximized, so it means that it is changing the state of matter from the first state to the second state, which is from solid to the liquid, right? And this is what? This is melting. You can see further here on the screen that if the temperature continues to increase, like if we are continuously increasing the temperature, so what will happen? Then at a certain point, so there is a point that comes at which point the intermolecular space between the molecules of the solid increases to such an extent that it starts changing into a liquid. So what will happen? To a certain point, to a certain limit, the temperatures rises to a certain point, that what happens? That the solid states change into the liquid one. You can see here that this is the example of a melting ice cream, right? You have already seen the diagram of the picture of the ice cube. So also you have seen this practically, that when we give some temperature, like we rise the temperature of the ice cream, it starts melting. What happens with it? Basically what is happening, the intermolecular space between the molecule is maximized and thus it changes itself from solid to the liquid state, right? I hope this is clear to you. Now moving ahead, you can see here on further heating, more solid changes into liquid, but the temperature remains constant. Okay, so what is the final definition of melting or fusion? Like what is melting or what is fusion if it is asked in the examination? So the process of conversion of a solid into its liquid state at a particular temperature on heating is called melting or fusion, and that particular temperature at which the solid changes itself into the liquid one, so that particular temperature is known as melting point, right? So the temperature at which a solid melts and changes to a liquid is called its melting point. For example, ice changes into water at 0 degrees Celsius on heating. So ice is changing itself into water at 0 degrees Celsius on heating. You can see in the picture over here that solid is changed into liquid when energy in the form of heat is given to it. Like we are giving the energy in the form of heat to it, right? We are rising the temperature. So what will happen? There is some sort of the rise in the kinetic energy, and because of the rise in kinetic energy in the molecules will start vibrating. They will just move apart from their position, and the intermolecular space will maximize, and thus it is resulting into the liquid form, right? So solid will change itself into liquid after the increase in the temperature. I hope this is very clear to you. You can take the screenshot of this, that this is the melting and fusion topic, right? Moving ahead, you can see in the next topic or the next conversion is freezing. So generally we know that what is freezing? Freezing is just when you are like lowering the temperature of a liquid into solid, right? You are just lowering the temperature so that the liquid changes itself into solid. That is known as freezing. You can see that when the temperature of a liquid is decreased, its molecules lose energy and slow down. Now what will happen if we are decreasing the temperature? Its molecules will lose kinetic energy, right? I have told you that if we are increasing the temperature, the molecules gain some sort of kinetic energy, but when we are decreasing the temperature, the molecules will lose some sort of kinetic energy, and thus they will come close to each other, resulting into the minimum intermolecular space, right? As a result, the intermolecular forces of attraction between them increases and they come close to each other. With continued cooling, the intermolecular spaces decrease to such an extent that the liquid changes into its solid state. Now when we are continuously decreasing the temperature, what happens? That the intermolecular space becomes so minimum such that the liquid is changed into the solid state. You can see here also that this is liquid, this is water, and it is freeze into ice. Yeah. So this is how freezing occurs, right? Moving ahead, you can see here that freezing is what? The process of conversion of a liquid into its solid state at a particular temperature on cooling is called freezing or solidification, right? So whenever we are lowering the temperature, the liquid changes itself into its solid state, and that whole process is known as freezing or solidification. But the temperature at which liquid changes itself into solid, that temperature is known as what? Freezing point of the liquid. The temperature at which a liquid freezes to become a solid is called the freezing point of the liquid. For example, water changes into ice at 0 degrees Celsius on cooling. So water is changing itself into ice at what temperature? At 0 degrees Celsius. Always remember, this is a very important statement, that water always changes itself into ice at 0 degrees Celsius. 0 degrees Celsius is the freezing point of water, right? I hope this is very clear to you. Now moving ahead, there is another topic or another process, that is boiling or vaporization. Now what is boiling generally? You have seen, I think you have must seen the boiling of water in your houses, right? Your mother boils water or either you boils water. So what happens? That when we boil water, we are increasing the temperature of the utensil, right? We are increasing the temperature of water. After increasing the temperature one by one, what happens? That after some time we see that water starts bubbling out, right? And those bubbles are just because of the gaseous vapor, or we can see the vapor formed in the water itself, right? So this is the boiling process. Now what happens in the boiling process? The whole water molecules are heated up. Okay, so we are rising the temperature of the each and every molecule of the water, right? That process is known as boiling. When liquid changes itself into the vapor state or in gaseous state after giving some sort of temperature, that is boiling. Okay, always remember that. So when a liquid is heated, its molecules gain more kinetic energy. They start moving faster. As a result, the intermolecular space between them increases. So what happens when we are increasing the temperature? After increasing the temperature, the kinetic energy increases, and because the kinetic energy is increased, it results into the motion of the molecules, right? And because the molecules start moving, it results into the maximum space, maximum intermolecular space between the molecules, right? At a certain temperature, the molecules are able to overcome the intermolecular force of attraction and escape into the space above the liquid. In other words, liquid gets converted to gas, right? So this is what is about boiling, the whole process. So general definition of boiling is what? The process of conversion of a liquid into its gaseous state at a particular temperature on heating is called boiling or vaporization. It is very easy. I hope you understood this, that whenever any liquid changes itself into the gaseous state, it is what? It is boiling or vaporization, right? The temperature at which a liquid boils and changes rapidly into a gas is called the boiling point of the liquid. As you can see here as well, the boiling is what? The change of the liquid into its vapor or gaseous state, right, after giving some sort of temperature. Okay, I hope this is very clear to you. You have seen here as well that when the liquid changes into gaseous state, that is known as vaporization. So boiling and vaporization is same. Okay, the name is although different, but boiling and vaporization is same. Now what is here given? For example, water changes into steam at 100 degrees Celsius on heating. So whenever we are heating water, 100 degrees Celsius is the boiling point of water. Okay, water starts boiling at 100 degrees Celsius. What does it mean? That the water is changing itself into the gaseous state at 100 degrees Celsius. Okay, I hope this is very clear. Moving ahead, you can see here that the next process is evaporation. Now what is evaporation? Some students got confused in boiling and evaporation. See, there is the basic difference between boiling and evaporation. Boiling is the process of the whole content, but evaporation is the process only occurs at the surface of water. Now why I am saying so, you can see here that the temperature of a substance is the measure of the average kinetic energy of its molecules. Even though the average kinetic energy of the molecules increases with increase in the temperature, yet not every molecule has the same kinetic energy. So when there is a rise in the temperature, it is possible that each and every molecule is not getting the same kinetic energy. But what happens, that the water that is on the surface like this, the water that is the water molecules that are on the top surface, the kinetic energy of those water molecules are the maximum, right? And because the kinetic energy is maximum, so they just start vaporize themselves. Okay, and that's how evaporation occurs. Okay, moving ahead, you can see here that some have higher kinetic energy and some have lower kinetic energy. The molecules having higher kinetic energy are fast enough to overcome the intermolecular forces of attraction. So molecules which have high kinetic energy, they are just going to do what? They are just going to vaporize themselves from the surface, and that is known as evaporation, right? So you can see here as well in the diagram that evaporation is a surface phenomena, but when we talk about boiling, that is the whole content phenomena. That is the phenomena that occurs in the whole content, right? I hope this is very clear. These molecules escape from the surface of the liquid and convert it into vapors. Now what's the definition of evaporation? The process of a liquid changing into its vapor at any temperature below its boiling point. So whenever the water is going to change itself into vapor, okay, whenever any liquid is going to change itself into vapor at any temperature below the boiling point, that is known as evaporation, right? Evaporation is a slow process which takes place from the surface of a liquid. For example, water vapor is always added to the atmosphere by evaporation from the surface of water bodies which get heated up by the sun. Okay, I hope this is very much clear to you that what is evaporation and what is boiling. The basic difference between boiling and evaporation is what? I have told you that, right? Moving ahead, we can see here that the next process is what? That is condensation. So when a gas is cooled, its molecules lose energy due to which they slow down. So now what is condensation? Basically, condensation is the process of changing from gas to liquid. But how it will happen? How we can change gaseous state to the liquid state? So we have to just lower down the temperature firstly, and the other thing is that when we are lowering the temperature, the kinetic energy is loosed out, right? So whenever we are lowering down the temperature, there is some sort of energy that is loosed from the molecules of that matter. right? After that, what will happen? Because the energy is loosed, and then what will happen? The intermolecular space will be minimized, okay, and the force of attraction will be maximized, and that's how we will get back the liquid from the gaseous state, right? The intermolecular forces between the molecules increases, due to which the intermolecular spaces between the molecules decreases. At a certain point, the intermolecular spaces decreases to such an extent that the gas changes into its liquid state, right? After that, moving ahead, you can see here also, like here in the picture you can observe. Firstly, I'm going to give an idea about this picture. This is a cold water bottle, okay? This is a cold water bottle you have taken out from the refrigerator, and when we put this bottle on a table, what will happen? After some time, we will observe that the water droplets will reside at the outer surface of the water bottle. But how? How? Because there is not any kind of force in the water bottle, right? So what is happening actually, the basic principle of this is given here, that if you have a cold glass, like in the previous case we have taken the cold water bottle, but if we are taking a cold glass, what will happen? The warm moist air will just collide with the surface of the glass, and because the air has gas molecules with it, right? So H2O molecules, okay, so H2O molecules are colliding with the water, like glass of water, okay. So what will happen? So the temperature of the water molecules in the air will be lowered down, and that's how they will change from gaseous state to the liquid state, and they will stick at the surface of the glass of water, and that's how condensation happens, right? This is also written here that the definition is the process of conversion of vapor or gas into its liquid state at a particular temperature on cooling is by called condensation, right? So the temperature at which a vapor or gas changes to a liquid is called the condensation point. I hope this is clear. Of the gas, for example, steam gets converted to the water at 100 degrees Celsius. Always remember, when we want to change steam into water, like steam into liquid, okay, so that's the temperature. The temperature is the condensation point at which the steam or the gas changes itself into the liquid state. So whenever we want to change steam into water, so the temperature condensation point is what? 100 degrees Celsius, right? I hope this is very clear to you. Now, moving ahead, we have the next process, that is sublimation. So in general, sublimation is what? The change of state from the solid state to the gaseous state directly. Right, you can see also here that generally in solids, the forces of attraction are so large that there is very low chance that its molecules will escape from its surface. We know that very well, right? But in some substances, the molecules readily escape from its surface and gets converted into the gaseous state directly without passing through the liquid state. But in some cases, we just observe this type of conversion. And this is also happening here. You can see here that this is dry ice, and when the dry ice comes in contact to the atmosphere, what happens? That it changes itself directly into the gaseous form. It is in solid form and it is changing itself into the gaseous form, right? So this is what? This is sublimation. You can see here further that the process definition is given here. Sublimation is a process by which a substance directly changes from the solid state to its vapor, that is gaseous state, on heating without passing through the liquid state. You can see also here that this is solid and it is converting itself into gaseous state, which is sublimation. But when gas are converted, the gas molecules are converted into the solid one, it is known as deposition or solidification. Remember that. Okay, I hope this is very much clear to you. You can take the screenshot of the definition now. Moving ahead, you can see that the examples are over here about the sublimation. The very first example is of iodine, solid carbon dioxide, also known as dry ice, ammonium chloride, camphor, anthracene, and benzoic acid are examples of a few solids that sublime. So these are the example of some solids which sublime themselves directly from the solid state to the gaseous state, right? Dry ice and naphthalene sublime at room temperature. Always remember that dry ice, that is solid carbon dioxide, and naphthalene. Naphthalene is this, the naphthalene balls that you keep in the wardrobes, okay, in the clothes basically. So these are the matter which just sublime themselves at room temperature. Naphthalene balls, commonly known as mothballs, are used in stored clothes to repel insects. They sublime at room temperature and with the passage of time become smaller in size. Okay, so with the passage of time, they are going to smaller in size. Okay, I hope this is very much clear. Now, moving ahead, you can see that we have the concept map about the conversion of the state of matter from one state to the other when the solid is changed into the liquid. So we are calling it as melting. Liquid changes itself into the gaseous state, so it is boiling on heating, right? So when gaseous state or the matter which is in the gaseous state, it changes itself into the liquid, it is known as condensation. And at like condensation happens on cooling, okay, and then liquid changes itself into solids, that is known as solidification or freezing on cooling. Okay, I hope this is clear. Now from solid to gaseous state directly, it is known as sublimation, which happens on heating, and from gas to the solid state directly, it is known as deposition. Okay, I hope this is clear. So moving ahead, we have the next topic, that is transfer of heat. Now somehow in some matters transfer of heat occurs. Why solid is changing into liquid, liquid is changing into gas? That is happening because the heat is transferred from one molecule to the other molecule in solid, liquid and gas. The transfer of heat in the molecules of solid from one end to the other end, that is known as what? That is known as conduction. Remember that conduction of heat and kinetic theory of matter, we are going to study it. So the mode of transfer of heat from one molecule to another without the actual movement of molecules from their mean positions in solids, always remember in solids, that is known as conduction. Like here we are heating this molecule, these molecules are here, we are heating them, so they will just pass on this heat from one end to the other like this. Yeah, so this is how we can say that heat is transferred from one molecule to the other molecule in the solids, and this process is known as conduction. So for example, you can see here that consider a metal spoon used for stirring while cooking. When we are using a metal spoon while cooking and we are using it as a stirrer, so the molecules present at the lower end of the spoon gain heat from the hot food, which causes their kinetic energy to increase, right? They start vibrating about their mean positions with the larger amplitude. In doing so, these excited molecules collide with the neighboring molecules and transfer heat energy to them, causing them to vibrate faster as well. Like in this case, this is a metal, and if you are heating one side here, so it will just transfer the heat to other molecules in the whole metal. Yeah, so this is how the heat is transferred from one molecule to the other in the solid. And here as well, like if you have a spoon in a bowl in which some sort of food is kept which is heat hot, okay, so what will happen, that from this end of spoon the heat will be transferred here, right? And this is what is defined here, that this process continues across the length of the spoon, causing heat to get transferred from the hot end to the cold end. This happens until the temperature of the whole body becomes the same, that is all the molecules are vibrating with the same energy and amplitude, right? This will happen until unless the whole spoon will get a constant temperature, or we can say equal temperature all over the surface, right? Moving ahead, we have the next process of transfer of heat, that is convection. Convection always happens in liquids and gases, always remember that. So in liquids and gases, molecules possess weaker intermolecular forces of attraction and thus have a tendency to break away from each other when supplied with adequate heat energy. The mode of transfer of heat energy, where the particles of a fluid actually move from a place of higher temperature to a place of lower temperature, is called convection. I have told you that what is convection. This is, you can see here in the picture as well, that convection is this process. Okay, so moving ahead, there is further explanation about this process, that when a fluid is heated, its molecule close to the heat source absorb heat energy and rise upwards. What would happen, that the molecules here close to the heat source will gain heat energy and will rise upwards like this, okay, and the molecules which are on the other end, those which are cold, they will come down here like this, okay. So this will happen here, the upward movement of molecules causes a fall in that region. To equalize the pressure, colder molecules sink pressure in downwards and get heated in turn, thus rising again. This movement of particles sets up current called convectional current, and thus this movement of whole particles from down to up and up to down, this will set up a convectional current. Convectional currents plays an important role in weather phenomena such as rainfall. Okay, I hope this is clear, that what is conduction and what is convection. Okay, moving ahead, we have a concept map of the whole chapter. You can see here. So in the whole chapter, we have studied about the matter that is made up of elements, and the smallest unit of matter is atoms that are combined to form molecules. Molecules possess kinetic energy, we know that, and molecules exert force of attraction as well between same kind of molecules and between different kind of molecules. The force of attraction between same kind of molecules is force of cohesion, and force of attraction between different kinds of molecules is force of adhesion. Okay, molecules motion explained using kinetic theory, which explains the transfer of heat by conduction and convection. We know that right now, we have studied about that, right? And molecules arranged in solid, liquid and gases. When solid changes itself into liquid, that is known as melting. Liquid changes itself into gases, that is known as boiling. When gas changes itself into, that is known as condensation. And when liquid changes itself into solid, that's known as freezing. So in the case of solid, it have definite shape and volume. These are tightly packed. It can't be compressed. They have strong intermolecular force of attraction. We have studied, right? And in the case of liquids, they have definite volume but no definite shape. They are loosely packed. They can be slightly compressed. They have weak intermolecular force of attraction. In the case of gases, no shape or no volume. They have no definite shape and volume. Move independently, easily compressed, negligible intermolecular force of attraction between them. So this is what is all about this chapter, this whole chapter. I hope you enjoyed the whole chapter in these 3 sections. Till then, what you have to do, you have to revise the whole chapter, take care of yourself, keep learning and keep exploring. Thank you so much. Bye-bye.